Hello friends, welcome to our channel. Let's have a look at a newly appeared problem. Problem 3476, maximize profit from task assignment. So in this video, we are going to explain how to design the code. So what we design is a solution based on the Dictionary of Min Heaps. So our plan will be the following. First, we are going to do the coding, and then we are going to walk through the examples. So personally, I feel that this problem is rather verbose. Basically, you just need to follow exactly the statement, then translate them into coding format. So here we are given an array called workers. So workers I represent the skill level of the ith worker, or you can understand it as a canned. You are also given a 2D integer array called task, where each task's element is a length 2 list. The first element is representing the skill requirement. The second one is the profit earned for completing that task. So each worker can complete at most one task, and they can only take a task if their skill level is equal to the task's skills requirement. So because of this sentence, we can understand the skill level and the skill requirement as canned. As long as the canns match, then a worker can be assigned to finish its work. So an additional worker joins today and who can take up any task, regardless of the skill requirement. So we want to return the maximum total profit that can be earned by optimally assigning the task to the workers. So here, optimally, so basically, if we have same canned task like this, here we have both threes. So we need to first finish the ones with more profit. So this is the one principle. Another principle is the additional worker. So you need the additional worker to finish the largest profit work remaining, right? So if you look at example 1, so 1, 2 can finish this 2, right? So we have 3. So we first use this 3 to finish the 400 one. And then we use the extra worker to finish this 100. Because there's no 4 and 5, we cannot assign them tasks. So this is the example 1. So example 2, so you have this task type is C1. So here no worker matches the skill set, so we can only use one additional worker. But because for that worker, the task can't or skill requirement does not matter, so we can just collect this 100. So for this one, no task, this can't does not match the keys 3 and 3 here. So we just use one extra worker, so we can get a profit of 3. But the two tasks have the same can and same profit, but you can only pick one of them. So that's all, right? So actually for this problem, the coding would be rather short. So here we have the length is bounded above by 10 to the power 5, which determines the problem size. Others are some consistency or just traditional extra assumptions. We're not going to go into details. So with that said, let's design the code. First, I'm going to collections default dict. So I'm going to use an list, right, as a container. Then at first I'm going to build this dictionary of min heaps. So basically for count and value in tasks. So what we want to do is heap q, heap push. So we want to push the canned. Notice that if canned is not in the dictionary yet, so this corresponds to an empty list due to our initialization. Then we are going to push this, but because I'm going to use min heap, so later I want to use heap. So I want the smallest one corresponding to the largest profit, but in this I need to put a negative sign. In other words, if I do pop operations, then put -1, then that's corresponding to the largest profit, right, for that count. That's it, right? So now let's get the result first. So the result will be 0 set, And then we are going to linear scan the workers, right? So for count in workers, if count not in D, right? We just continue, right? Otherwise, what we do? So no, let's if count not in workers, so we continue. Otherwise, let me write like this. If count in D, what we are going to do things. Otherwise, we do nothing, right? Otherwise, we just get out this this current iteration. Let's write it like this. Then, if not count, not D count. In other words, there's no such type of task to assign. Then the corresponding worker cannot be assigned works. So we just continue. Otherwise, so we are going to assign a work, but we only focus on the profit. So here I'm using minus because what I stored is negative. So here heap q, heap pop D count. This makes sense because we have checked this if, right? So in other words, when we enter this this line, D count must be non-empty. So if it were if it's not an empty say heap, so when we do the pop operation, you are going to get the smallest value because here is negative. So we minus this one. That's the increment of the profit, right? Then we just done, right? So if you enter this one, basically no task to assign. If count not in D, so you cannot assign a task for sure. So now we want to, this is using the workers here. So now we want to check what we can assign to the additional worker, right? So let's say min equals 0. Let's use a min hyphen, right? So then basically we focus only on the current state of the possible tasks for v in D values. So notice this v are heaps, or you can interpret it as list. So if v is not empty, so min will be minimum of the previous state at v naught, because at v naught will be the corresponding smallest one, right? Because here I'm going to use return result minus min hyphen, right? So if all the tasks are already assigned, so this actual worker cannot be assigned work. So we are not in actually there's no effect. We are minus 0. If there's still task, this min hyphen will add line will be smaller than 0. So here we are overall adding something. That's the overall logic. Now let's run it. It passes the 3 test cases. So now let's look at the generic case. It passes all the cases. So now let me do some print to help you digest, right? So first, I guess it might be important to print out this D, right? So let me use f string D, right? So, for this one, type 1, you have negative 100. Type 2, you have negative 400. Type 3, you have negative 400 and negative 100, right? So now if we look at the workers, so you have a type 1 worker, so you get 100. And you have a type 2 worker, you get get 400, that's 500 now. You have type 3, right? You can assign this one, you get 900, right? So now, because this are already this one used, only the type 3 workers still have negative 100. But 4 and 5, you do not have such cans, so you cannot assign this negative 100. But we have an extra worker, so it can take this one, right? That's the first example. So if you look at the second example, so you have only one task type, one corresponding to a negative 100. If you linear scan this list, so no key, you can regard this as key, is matching this one. So you are going to finish this loop without doing anything. In some sense, I mean, do not collect profit. So then we can only use the extra worker to get this 100. So for case 3, so we have 3, right? We have -3 and -3. But here the worker count is 7, does not match this key. We need to use a extra worker, but it can only absorb 1, so we get 3. And there's a task of a recurring skill level 3 or count 3 is remaining, right? That's the third example. So I guess that's it for the current video. If you look at our code, so first we build the dictionary of min heaps, and then we just translate this paragraph, right, into the code here. This is the first assign, and then use the extra worker. Let me do this. Assign tasks according to count, in other words, skill level. So this one is assign extra worker task, a task. If there are still remaining tasks, right? That's all, right? So basically, that's why I'm saying that this problem is rather verbose. So with that said, that's about it for the current video. So overall, I would like to demonstrate that. So when you write code, you can have some design. So here I'm using dictionary of min heaps, and actually the code is not very long. So with that said, I guess we indeed should end this video now. Thank you for watching.